here is how we solve exponential functions. It's some extra practice. And again, even before I read the directions, remember that the key is to isolate as much as possible. If you can isolate, you can solve these problems. And it says, use common or natural logarithms to solve. Leave answers in exact form as well as approximate form. Round your answer to the nearest 10,000. 4 decimal places. Check your work using your graphing calculator. So as we take a look at this first one, what I notice immediately is it's 5 times e to the 4th x. So we're going to divide both sides by 5. When we do that, we're left with e to the 4x equals 16. Well, in order for us to solve that, we're going to have to use a logarithm. And because there's an e in here, I'm going to put in a natural log. So this becomes natural log of e to the 4x equals natural log of 16. And then we're going to use our power rule, which says that we take the 4x. We're going to write it out in front of the logarithm here. So now what we have is we've got 4x times the natural log of e equals the natural log of 16. And we want to solve. But another reminder is think about what the natural log of e equals. And the natural log of e equals 1. So I know not everybody's going to write that down. But I don't want you to forget about the natural log because this is an important part of the problem. So we get 4x times the natural log of e, which is 1. So ultimately it's just 4x equals the natural log of 16. And then finally, to find our exact answer here, what we've got 4 times x. So we're going to divide those sides by 4. And our exact answer ends up to be x equals natural log of 16 divided by 4. That's our exact. If we want the approximate, we can pull out our calculator and we can type in the natural log of 16, close the parentheses, divided by 4, and that will give us our approximate value. And our approximate value, when we round to the nearest 10,000, we're looking at the 4 here in the 5th decimal space to determine what to do with that 1, but our approximate ends up to be then x equals 0.6931. Because 4 is less than 5, we leave that 1 alone. Problem number 2. Again, the key, isolate. So let's add 8 to both sides. And we have 10 to the x plus 5 equals 68. And in order for us to solve this, now once again we are going to have to put in a logarithm, and because it's a 10, we're going to use log, L-O-G, log. It's log of 10 to the x plus 5 equals log of 68. And if you've been doing all your practice, you know the pattern by now. You're taking this value, I'm going to write it out here in front. Now we have x plus 5. It's the whole value, so I'm going to put that still here in blue. X plus 5 is going to be multiplied by log of 10. And over here, then we have log of 68. And the thing is, typically what we would do is we would distribute log of 10 over the x and the 5. But if you think about it, the base of a common logarithm is 10. So the log base 10 of 10 is really 1. This value, log of 10 is 1 here, and then that's going to be multiplied by the x plus 5. And over here on the other side, we have log of 68. And you maybe didn't write that red 1 down because x plus 5 times 1 is just x plus 5 equals log of 68. And now we can get really close, or one more step, and we'll have our exact answer. We're going to subtract 5 from both sides. We get x equals log 68 minus 5. Remember that 68 is attached to the logarithm, so we can't subtract 5 from that number, 68. If it helps, put in a parentheses around there. That's our exact answer. And if we'd like to know what the approximate value is, we pull out our calculator, and we type in log of 68, close the parentheses, minus the 5. That gives us that screen here, and our approximate value is x equals negative 3.167. Notice here that the fifth decimal space is a 9. That's going to determine what happens to our 4. And because it's 9, which is 5 or higher, that 4 becomes a 5. Problem number 3. A little bit more complicated, but the good news is that the problem is already isolated. We don't have to move anything around before we can start this problem. And it just depends on your teacher. If you have Mrs. Krause, she's going to put natural log in for both sides, ln. And if you have Mrs. Danhoff, she's going to put in log. It doesn't matter which one you choose, but just stick with it. If you put ln in on one side, put it in on the other side as well. I'm going to put log in. It's going to be log of 5 to the 1 minus 2x. And it's log of 8 to the x. And like I said before, if you've been doing the practice, you know what the next step is. Because it seems that every problem has this in where we have to take that exponent and make it a coefficient. So it's 1 minus 2x is going to be multiplied by the log of 5. And over here on the other side, we do need to do that same process with the x and make it a coefficient. So this is going to be x times log of 8. And on this problem, we're not so lucky. We are going to have to distribute the log of 5. Log of 5 is going to have to be multiplied by the 1, and the log of 5 is going to have to be multiplied by that 2x. So we get log of 5 minus 2x log of 5 equals x times log of 8. Well, our ultimate goal here is to solve for x. So we need to put all of the x's in on the same side of the equation. So let's add 2x log 5 over here to the right side. We have log 5 equals x log 8 plus 2x log 5. And again, what we're trying to do is we want to figure out, well, what does x equal? And because we've got an x in 2 terms here, we have to factor out the greatest common factor of an x. And now we're left with log of 8 plus 2 log 5. And over here on the left side, we still have our log of 5. But we have our problem in a format that we can simplify now, because it's x times that value in parentheses. We're going to divide by log of 8 plus 2 log 5. And over here, we're going to do the same. Divide by log of 8 plus 2 log of 5. And that ends up to be our exact answer. Log of 5 divided by log of 8 plus 2 log of 5. That's our exact. And if you have a calculator here to find the approximate value, I recommend using the fraction button. On this particular example, I will type it in without the fraction button. And it's just a matter of the parentheses here. So it's going to be log of 5. And actually, I think I can do it out. I'm going to start over here. I'm going to do parentheses. Log of 5. Close, close, parentheses. Divided by parentheses. And then we have our log of 8. Log of 8. Close the parentheses. Plus 2 log of 5. Close the parentheses for the 5 and then close it for the entire denominator. And when we finish, we have that value here, which is going to give us our approximate value. And our approximate value, better look to see where we're going to round, since we're rounding to the nearest 10,000. And on this one, we're looking at the 6 here, the 5th decimal space. And that's going to determine what we do to that 7. But what's going to end up is we're going to end up with x equals 0.3038, because 6 is 5 or higher, and that's our approximate solution to this logarithmic problem.